Today's lesson is section 1.6, day 1, and we're going to work on solving polynomial equations of higher degree. Right, so we're going to start off by using some of the methods that we use to solve quadratic equations to help us solve some of these equations of higher degree. So we might eventually end up employing some type of factoring method or breaking something down, so that way we might be able to use quadratic formula. And we also, later on in some of the examples, when we get into some fractions, we might have to start solving some of those equations by either the LCD method or by finding common denominators. So let's go ahead and get started. So first of all, there's the formal definition of a polynomial, but what we tend to know it as is our example of 2x to the fourth plus 8x cubed minus 5x squared plus x minus 13. So something that looks like that. So a higher degree just means something higher than an exponent of 2, so something that's not quadratic. So let's take a look at our first example. It says to solve 3x to the fourth, and that is equal to 48x squared. So anytime we see that there is more than one x in an equation, we know to get all of the x's to one side. So let's go ahead and do that. Get a different color. All right, so I'm going to, since x to the fourth is on the left-hand side, we are going to go ahead and move everything to the left-hand side. So that means 3x to the fourth, and then I'm going to move the 48 over by subtracting it, so minus 48x squared equals 0. So now that it's equal to 0, I'm going to say, okay, is there a greatest common factor that I can pull out of both of these? The answer is yes, and it is 3x squared. So if I factor out a 3x squared, I'm left with x squared minus 16 equals 0. And now we're going to use that zero product property that says if I have two things being multiplied together, or how many ever things being multiplied together, and it's equal to 0, at least one of them has to be 0. So that just means we set each of them, each factor, equal to 0 and solve. Something else we could have done at this point is we could have said, oh, I can factor this even more into x plus 4 times x minus 4. And then we would have set each of them equal to 0, but I'll show you why I did not have to do that. So if I solve 3x squared equals 0, I'm going to divide both sides by 3, so 0 divided by 3 is still 0. And then the square root of 0 is plus or minus 0. Might look like, oh, why do we need to put both of those? But trust me, in the near future, the plus or minus 0 is really going to be helpful. Okay, once we get into chapter 2. The second equation to solve, I'm going to add 16 to both sides and then take the square root. So here's where, if you can remember to put the square root of 16 as plus or minus 4, you don't have to factor the x squared minus 16. If you know you're going to forget that, then come over here and solve them to see how I would get a negative 4 there, and here I would get a positive 4. Okay, so those are my two answers. I should say my 4 answers: positive negative 0 and positive negative 4. All right, so you can pause the video, try the your turn, and I'm just going to go ahead and write the answers down. So pause it, work on it, come back and check them. All right, so the solutions to this problem are plus or minus 0 and plus or minus 3 root 2 over 2, and that is the rationalized answer. Okay, so just to make sure you have that one rationalized. All right, example 2. If we look down to example 2, the first thing I notice, there is an x cubed, an x squared, an x, and then a constant term, meaning we have 4 different terms here. So anytime we have 4 different terms, that means we need to factor by grouping. Now remember, anytime you factor by grouping, you always want to leave a plus sign in the middle. A subtraction symbol is not acceptable. It has to be a plus sign in the middle. Okay, so looking at my first 2 terms, I can factor out an x squared. I'm left with x minus 3. My second 2 terms, I can factor out a 3, so I'm left with x minus 3. Don't forget, this is a great time to check if what you have in the parentheses is the same. That means you're on the right track. Then we say, okay, what I have inside my parentheses is x minus 3. What I'm left with is x squared plus 3. So now I'm going to set each of them equal to 0 and solve. All right, so that means x is going to equal 3. And x is going to equal the square root of negative 3, but we learned the other day that I can factor that I out. Don't forget plus or minus. And there we have our solutions. All right, again, pause the video, try this your turn, and then come back and check your answers. All right, example 3. So now we're looking at this and we're thinking, okay, I see x to the 4th, not a big deal. But then we look and say, oh, there's only 3 terms. So how are we going to solve something like this? And I know you guys have done this before. So we actually just treat this as an x squared problem. So if we wanted to be technical, we would say, okay, I'm going to let u equal x squared. Okay, so that means this would be u squared minus 3u plus 2 equals 0. Okay, because if u squared is just x squared, or if u is just x squared, I would have x squared squared. So that's where we get the x to the 4th. So now factor this like normal. So I need 2 numbers that add together to give me negative 3. But when I multiply them, I get 2, where the only numbers or factors of 2 are 1 and 2. So they're both negative, and let's double check. Negative 1 plus negative 2 is negative 3. Negative 1 times negative 2 is positive 2, so we're good to go. And that becomes u minus 1 times u minus 2 equals 0. And now I'm going to go ahead and replace each of these with my x squared. So this then becomes x squared minus 1 times x squared minus 2 equals 0. Set each of them equal to 0. And then go ahead and solve. So x squared equals 1, x equals, don't forget, plus or minus 1. Over here, x squared equals 2, and x equals plus or minus the square root of 2. So again, we get 4 different answers. All right, moving on to example 4. So here's where we have 2 options or 2 different ways to solve the problem. One method is to say, okay, if I look at all the denominators, so if I put that 2 over 1, this right here is really x plus 1, x minus 1. Just like normal, if we were trying to find a common denominator, we would say, hey, the common denominator is x plus 1 times x minus 1. So what I'm going to do is multiply the entire expression by x plus 1, x minus 1. Okay, so that means every single thing. So both sides, every term. Here we go. So if I do that, my 3x is still here in the numerator. I already had an x plus 1 in the denominator. So, you know what? I'm going to show this multiplication. I think it'll make a little more sense. So if I have 3x times x plus 1, it's going to look like a lot of work, and I know a lot of you are going to do this in your head, but I just want to physically show it. So what I'm doing is multiplying every term by that. All right, so I kept all the denominators the way they were. I just literally multiplied every single term by x plus 1, x minus 1. Okay, so now since this is one fraction, those 2 cancel because it's already in the numerator and denominator. So I get 3x times x minus 1 equals, hey, those all cancel since I'm multiplying by it, so I just have a 12 there, plus 2 times x plus 1 times x minus 1. All right, so I'm going to distribute, so I get 3x squared minus 3x equals 12 plus, remember this right here was just x squared minus 1, so 2x squared minus 2 once I distribute. All right, so now I can get everything to one side. So I'm going to subtract 2x, so I have x squared minus 3x. 12 minus 2 is 10, and when I move that to the left-hand side, I get minus 10 equals 0. So now I see this is quadratic. You could use completing the square quadratic formula. I'm just going to factor. So -3, -10. So factors are 1 and 10 and 2 and 5. So I do have 2 and 5 as my options. So it's going to be a -5 and a +2. So x plus 2 times x minus 5 equals 0. So x is going to equal -2 and +5. Okay. I will show you the other way now, because I know in class the majority of people did not prefer that LCD method, but I wanted to show that first this time. Maybe since we've been a little more comfortable with it, that maybe that would look better. It is a little bit easier that way. But now let me show you the other method, which is where I'm going to find a common denominator for all of them and then cross multiply, and you'll see how it ends up. So if I get everything to one side, sorry, line 2, that is a -2/1. Okay, so I got everything to one side. That way I can just have all of my fractions together. I could have left the 2 over there, but it's all the same process. Okay, so common denominator is going to be x plus 1 times x minus 1. So this one, I already had the 3x, and I was missing my x minus 1. Minus the 12, I already had that, so I don't need anything there. Minus the 2 only had a denominator of 1, so it was missing both of them. So in my numerator, I get 3x squared minus 3 minus 12 minus 2x squared plus 1 plus 2. I forgot to distribute the 2. There we go. And now that I have one fraction equal to something, I would cross multiply. So if I could put 0/1, but 0 times that denominator, it's just going to go away. So all I'm left with is the numerator equal to 0. And then you can see hang on, forgot my x there. Now let me fix this. There we go. Now I have x squared minus 3x minus 10 equals 0. And we end up with the same quadratic function to solve. Okay, so either way. All right, you guys have an A and a B. Your turn to try if you would like. Like I said, pause the video, try it, come back. I'll have the answers for you.